Morning. So today we're here to talk about slope. I know you had a question about it. You're learning about it in class. I want to help you really understand slope from the ground up. No pun intended. Okay, so slope, as you might know in language arts, it sort of means like how steep or how flat some land is. Like if you're skiing, you think about the slope. And with my hand here, there's really no slope here. My hand's kind of flat. And as it goes up, the slope increases until it becomes totally vertical, and that would be a really scary mountain to be on top of, but they're out there. So today we're going to talk about slope, and in math, it can be defined, it can be given a value, like a number, and we're going to get there today. So here we have two lines. Each one represents a different slope. Now, as I said before, I think it might be easier to see that the purple line is a steeper slope than the blue line. Now mathematically that's going to happen, and here's how. Let's think about this in context first. First of all, let's think about these lines as being showing how fast two cars travel. And so in a given number of minutes, cars travel a certain number of miles. And 0, 0 being our point of origin here, we can see that as cars travel per minute, the blue car travels one rate and the purple car travels at a different rate. 7, 8, 9, 10. Now let's even look, it might be hard to see, but look at minute 1. After 1 minute, the blue car has gone 1 mile, the purple car has gone 2 miles. So maybe we can call the blue car a Buick, and the purple car could be like a Ferrari or something. Much faster than a Buick. At least the driver's driving it faster. So, okay, so back to the slope. They have different slopes, as you can see visually. Now here's how you think about them mathematically. Slope is really a ratio that is represented as a fraction, the rise over the run. And as you might assume, a rise is vertical, up or down. And the run is horizontal, like left or right. So looking at our Buick, we know it goes a mile every minute. And so I can sort of see that as I build a set of stairs. I can see if I rise up 1 mile, it took a minute. So it's a 1-to-1 relationship. And from minute 1 to minute 2, it's gone another mile. So I rise 1 and run 1. Again, I rise 1, run 1. It represents a mile per minute right there. Once more, we went 1 mile in 1 minute. 1 mile in 1 minute. That's my small staircase. See it right there. Okay, now let's look at the Ferrari. It's going to have a steeper staircase. It has a steeper slope. Here, it goes 2 miles per minute. Again, 2 miles per minute. And once more, 2 miles per minute. Okay, so again, back to the math over here. Rise over run. The Ferrari is going to have a rise over run ratio of 2 to 1. That's the slope for the Ferrari, 2 over 1. And the Buick has a slope of 1 to 1. Now this is the ratio. It shows rise over run. We can also call it a rate of change. And as a rate, this is slope 2 over 1. It's an improper fraction. What is 2 over 1 as a whole number? 2. And what is 1 over 1 as a whole number? Good, 1. So as you can see, the Ferrari has a slope twice the Buick's, which is 1. So we'll talk next time about how to use the slope formula, which involves picking out points, and I'll show you how that works. It's really cool and easy to remember.